Moving forward with this European Commission report on guidance, let's look at the key steps of the guidance. So a wide array of adaptation options is available, but more extensive adaptation than is currently occurring is required. The guidance provides a framework to develop step-by-step adaptation strategy, taking into account the usual barriers. Key steps for the development of an adaptation strategy illustrated in the guidance are, so we'll look at each chapter as we go forward. Establish the policy, legal and institutional framework. Understand the vulnerability of the society. These are points we made, but they are worth making again. Develop, finance and implement an adaptation strategy. We talked about this from the very beginning, including the World Bank report. No matter how reliable the risk information and climate projections get, unless adaptation is mainstreamed into fiscal policy and budget process, it's going to be an impossible task. And doing that also then requires tracking vulnerabilities and setting up protection mechanisms, social protection for those who are most vulnerable, right? So the evaluation of the guidance part will be in chapter 9. So here is the framework and steps for the development of an adaptation strategy. So here we start with policy, legal and institutional framework required for adaptation. Understand the vulnerability, so information needs, impact assessment and vulnerability assessment. We already talked about this a little bit. Develop and implement measures, so financial arrangements are needed, and then evaluate and come back to the iterative step of understanding the vulnerability with the previous steps. Okay, core principles and approaches. Adaptation can and should build upon the numerous water management measures which are already available and implemented. Just like we said, health adaptation has to be synergistic with the existing health systems. Any adaptation you are going to develop with present risks and future risks have to be synergistic with the water management systems that already exist. Adaptation needs to be cost effective, environmentally sustainable and culturally compatible and socially acceptable, as we already read. Any adaptation policy should consider climate change in the context of many other increasing pressures on water resources such as population growth, globalization, changing consumption patterns and industrial development. We mentioned this as well. Adaptation policies should be developed within the context of the integrated water resource management, which involves planning at the level of river basin, strong intersectoral cooperation, public participation, and optimization of the use of water resources. I repeat some of these things because people may only listen to this podcast and not all of the ones before. So even if you are listening to all of them, hearing these points again is obviously very useful. Effective transboundary cooperation should be measured at all relevant stages of decision making, planning and implementation. Transboundary cooperation is very critical, and it also says that as comprehensive as you may be in developing your national adaptation plan with health and water and food in it and your NDCs, unless you have the map of the local water flows, transboundary sharing issues, and export and import of grains and other products that have embedded water footprint, you are not going to be very effective in your adaptation. Okay, it's not a standalone exercise. So that's where the transboundary issues are so important. Adaptation is not a once only exercise, but rather a continuous long-term process to be integrated into all levels of planning. Currently, short-term thinking is still too frequent. So we're always in a crisis mode because year after year, season after season, you have climate impacts, and there is very little fiscal room made and plans made for long-term resilience building with adaptation plans, implementations. Okay. Climate change is characterized by a high level of uncertainty and risk. Various methods can be used to reduce and manage uncertainty, especially at local levels. In any case, uncertainty cannot be a reason not to act, as we said. Instead, adaptation should start now while at the same time the knowledge base can be increased through focused research, a twin track approach that is needed here. Adaptation policy planning should consider and prevent possible conflicts between different water-related sectors. Trade-offs between adaptation and mitigation strategies should also be avoided. It's not one or the other. It's not a zero-sum game when it comes to adaptation and mitigation. You need to reduce emissions, reduce your GDP energy intensity and carbon intensity of the energy, and also adapt to the impacts that are expected to continue to happen or get worse. Adaptation should also include a disaster risk reduction strategy that must be grounded in local knowledge and communicated broadly so that every citizen is aware about possible personal adaptation measures. Health response systems can help in this regard. So Sendai framework for disaster management is a good example of how international protocols can be developed for disaster management in the context of adaptation, mitigation for every sector, not just for water. Okay, possible trade-offs between adaptation and mitigation measures. This is a good table. Examples of proposed mitigation measures and possible impacts on water resources. Mitigation measure, carbon dioxide capture and storage. So degradation of groundwater quality due to leakage of CO2 from injection and abandoned wells, leakage across faults and ineffective confining layers, local health and safety concerns, and possible positive effects could be reduction of atmospheric CO2, possible reuse of CO2 for industrial purposes, and also in production of biomass or even synthetic fuels and so on. Possible remedies and commitments. You have to be sure that carbon that's captured is not being re-released with synthetic fuels and so on. So possible remedies and comments: careful site selection, effective regulatory oversight, appropriate monitoring of the conditions of the storage sites, remediation methods to stop or control CO2 releases. Further research is needed. So I won't read the details of each of these, but geothermal energy extraction, you can have reduced greenhouse gas emissions, but you could have chemical pollution and other unintended consequences, so you need to find appropriate locations. Large-scale biofuel production is something that's being used extensively in future pathways for global warming targets and so on, but this is worth reading because possible risks for water resources are very critical to understand. Increased water demand, enhanced leaching of pesticides and nutrients leading to contamination of water, biodiversity impacts, conflicts with food production and land use changes leading to indirect effects on water resources, increased vulnerability to droughts, food security issues for the poor, and so on. But you can have possible positive impacts through reduced nutrient leaching, soil erosion, runoff, and downstream siltation, if done properly, of course. Possible remedies and comments. Energy production and greenhouse gas mitigation potentials of energy crops depend on many factors, including land availability, appropriate location. The previous land cover should be of lower value. Appropriate design and management are essential. Further research is needed. So this idea that degraded land will be somehow used to produce bioenergy crops has not really worked out so far, but nonetheless we keep saying that some bioenergy crops, biodiesel crops can be grown on degraded land. Okay, so that's a technological promise that has to be realized yet. Similarly, electric power plants for reducing emissions as a mitigation measure can have various positive and negative impacts. Land management for soil conservation, soil carbon conservation. Enhanced contamination of groundwater is possible with nutrients or pesticides via leaching under reduced tillage, which is part of the enhancement of soil carbon conservation. Erosion control, improved water and air quality, increase of food production, reduction of siltation of reservoirs and waterways is a positive impact that could come out of this. You also have agricultural intensification such as crop rotation, which can also help soil carbon conservation. So you can have crops with higher water demand being negative impacts, and again erosion control, etc., being positive impacts. So in terms of comments and remedies depends on region and conditions, use of innovative methods of precise agriculture, smart agriculture. For example, nutrients are injected into the subsurface precisely according to the need of the crop. But the data demand for these is very high, and it's not clear subsistence farmers can really do this. This works very well for industrial farming or rich countries, but we have to wait and see how this can help poor countries. Evaporative cooling in building can increase water demand but can reduce energy demand, so reducing the cooling load by optimizing building shape and orientation itself will be critical. Okay, that was a quick run through. Let's read a few more examples of adaptation measures in the water sector which can have negative impact on climate change mitigation. Adaptation measure in water management can be desalination of saline water for water supply. Always has high energy needs, so methods are still to be found for reducing water use. There are ways of using renewable energy like solar and wind, but scalable solutions are not yet available as far as I am aware. Remedies and comments. Mitigation impact depends on energy source, therefore use desalination only if no other choices, and use renewable energy. So water stress, water adaptation, additional water sources. Obviously there is a lot of ocean water, so if desalination can be done without exacerbating emissions and greenhouse warming, then it's a great way to solve water problems. Israel, for example, has done extensive desalination, and Middle Eastern countries have done it for a long time, but using fossil fuels for energy and so on. Reservoirs, hydropower plants can emit greenhouse gases as water conveys carbon in the natural carbon cycle and due to rotting vegetation. Mitigation effect depends on many factors, including depth of reservoir. Multi-purpose dams and appropriate location and management are recommended, but more research is needed again. Irrigation. Biggest demand for water in most places comes from irrigation, and next industries, and then domestic water use. And irrigation tends to be very inefficient unless there is drip irrigation done, but then drip irrigation is shown to increase water use unless there are regulations to limit water use along with drip irrigation. This can lead to high water and energy needs as well. And use efficient irrigation techniques for remedies drought resistant crop varieties. Mitigation effect depend on energy use. Okay, so we'll come back and look at policy, legislation and institutional frameworks in the next podcast. This one is about 13 minutes long, so that's good enough and remains together as a nice package. Okay,